In the 1950s, school children in the United States learned all the basics: reading, writing, arithmetic, as well as one other thing: what to do in a nuclear attack.
First, you duck, and then you cover. And very tightly, you cover the back of your neck and your face.
On October 4th, 1957, American fears of nuclear annihilation seemed to come one step closer.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket. You are hearing the actual signals transmitted by the Earth-circling satellite.
Shockwaves reverberated through the White House, leading President Eisenhower to make a massive investment in science education. The firepower of this Cold War would be devised by innovative minds, and to lead the charge, Eisenhower established a new federal agency, the National Aeronautics and Space Administration, NASA. As a new president, John F. Kennedy took the helm. The Soviets pressed their advantage.
Man had his first great success in space when the Russians pushed a man across the threshold. It was the propaganda coup of the year.
In response, President Kennedy threw down the gauntlet.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
And on July 20th, 1969, the world stood still as a decade of intense effort culminated with Neil Armstrong descending from the Eagle lander.
That's one small step for man, one giant leap for mankind.
But with that triumph, some Americans questioned the need for further investment in the space program, especially when down here on Earth, the country faced so many challenges.
Okay, Houston, we've had a problem here.
NASA's funding was cut significantly, and the last 3 Apollo missions were canceled. With that, NASA's focus for the 1970s and the 1980s turned to an orbital space station and a reusable vehicle to get there. And this time, NASA didn't go at it alone. Americans and their Soviet arch-rivals put aside their differences to jointly build and operate the International Space Station, a partnership group that has grown to include the Europeans, Canadians, and Japanese, whose own space programs grew considerably during the 1970s and 80s. By the late 1990s, Europe's Ariane rocket had become well established in the highly competitive market of satellite launches, and by the early 2000s, private enterprises such as SpaceX, Blue Origin, and Virgin Galactic brought space exploration into the realm of big business. Meanwhile, scientific exploration of the cosmos transitioned into a robustly international endeavor, with uncrewed missions probing every planet in the solar system. But to a species of explorers, nothing compares to the dream of human space exploration, and in 2022, NASA, in partnership with European, Australian, Japanese, and Canadian counterparts, launched the Artemis program to establish a permanent human presence on the moon en route to eventual human exploration of Mars. Probing farther still, a new generation of internationally funded space telescopes will seek to unravel the origin of the universe, the nature of dark matter and dark energy, and whether there is other life in the cosmos. Our next steps into space, the final frontier, will very likely revolutionize our understanding of the cosmos and our place within it. And so, with excitement and humility, we enter the new golden age of space exploration.
Good evening. Welcome. Thank you. It's been a long time since we've been here live, right? Last time we were able to join you in person was back in 2019. A lot has happened since. Of course, it is science itself that has allowed the world to start to get back to normal, right? It is remarkable how quickly the vaccine was developed and then ultimately tested, allowing us to get to a place where life is getting back to normal. There have been tremendous developments, of course, in the time since we have been here, because although the world had to sit still, science went forward. In a moment, we're going to take that summary that we just showed you and push it forward. And other programs that we will be talking about here at the festival, James Webb Space Telescope, we will talk about the insights and innovations from that particular machine. A whole variety of other developments will also be available. But there's one that perhaps I'll just quickly make a reference to, which is, the breakthroughs in artificial intelligence, which are pretty remarkable. I mean, how many people have played around, say, with ChatGPT, right? I'd say about half of you have, right? And it's impressive, right? It's impressive, but I have not been as really convinced as some that this system really is intelligent, right? In some ways it is, in some ways it's not. So, just to sort of give an example, just a couple hours ago, I asked ChatGPT to try to integrate it into the program to write me an opening joke for tonight's program. So I asked it to write me a joke about space exploration. And because I was thinking I might actually deliver that joke to you, I said, write it in the voice of Brian Greene. Okay, so it came back, and I'm going to give you this really rollicking piece of humor from this intelligent system. Here's the joke. The joke is, why did the astronaut cross the road? It's a promising start. The answer is, to get to the other side of the universe. Now, when I read that, as a humble representative of the species, I felt pretty good, right? Because, this is not really what I would call intelligent humor. So, I wrote back to ChatGPT and I said, that was kind of a lousy joke. I asked you to write a good one. Why did you write such a bad joke? And ChatGPT came back and said, well, you asked me to write it in the voice of Brian Greene. A little bit scary, right? Anyway, so tonight's program, we are going to travel across the cosmos to get an update, state-of-the-art look at what we have been doing in the arena of space exploration, broadly defined. Let me introduce Thomas Zurbuchen, who from 2016 to 2022 was the Associate Administrator for the Science Mission Directorate at NASA. That is NASA's head scientist, where he oversaw the development of many of the initiatives that we will be discussing here tonight. Welcome, Thomas. Also with us here in Brisbane is Aude Vignelles. Aude is the Chief Technology Officer of the Australian Space Agency, where she is responsible for defining the scope of Australia's space programs and managing their technical development and final delivery. Welcome, Aude. We have two other participants who are joining us remotely. First joining us from The Hague is Kirsten MacDonell of ESA, the European Space Agency. Kirsten is the Utilization Planning Team Lead at the Directorate of Human and Robotic Exploration, leading groups that are responsible for transporting European astronauts and payloads from Earth to the Moon and Mars. And finally, with us from Paris is Masaki Fujimoto, Deputy Director General of the Institute of Space and Astronautical Sciences of Japan's Aerospace Exploration Agency, or JAXA. His team has successfully intercepted and recovered samples from an asteroid and is currently planning a mission to return samples from one of the moons of Mars. All right, so welcome to everyone to this conversation. Thanks so much for joining us. And we're going to be exploring, the world wide effort, really, of our species to take the next step into the final frontier. And one of the big questions that we will be talking about, it's a question I think just about everybody has an interest in, which is, are we alone, right? Is there life out there in the cosmos? And just to get us going, I just want to ask everyone your sense. I mean, if we were able to answer that question, presumably in the positive, it'd be hard to definitively answer it in the negative. How much of a big deal would that be? I mean, what kind of impact do you think that would have, Thomas?
Look, Brian, I studied physics because of a class on history. And that was a class on the Copernican revolution, when scientists figured out that the sun was in the center of the solar system and not the Earth. It changed everything, not just our understanding of science, but the whole power structure, both on the kingdom side, but also the religious side. I think finding life is a similar type of revolution, kind of one that takes life from one life in our experience to many lives. I think it will be enormous in its impact, and frankly, hard to predict.
Yeah. Aude, how about your view on that?
I think I would agree with that. And I also think that discovering another extraterrestrial life, and it's not if, it's really when, and it's really, are we going to be able to discover that?
That's really confident, right? That's great.
Well,
okay.
The odds says and the probability says that there will probably be life out there, but how are we going to find it? But I think finding such a discovery, having such a discovery, will unite a lot of people as well. I think you've heard about the blue marble effect, when apparently when you go to space and you see how small the planet is, you really realize that we are one humanity living on the planet. I think if we discover that you're not the only one, it will change our perspective on things very much. So that will have a massive impact.
Hugely so. Kirsten, how about you?
Yeah, I think I agree with both Aude and Thomas. I realize that given the chances and all the stars in the galaxy, there's such a high probability that there is life existing elsewhere. And similar to the blue dot, blue marble feeling, you also may feel like, yeah, we really aren't alone out there. And maybe that helps us justify everything we're doing for planetary protection and see the universe as a space that we're sharing with other organisms.
Masaki, so what do you think? If we were to end cosmic loneliness and know that there are other intelligent life forms out there, what would the impact be? How big of a discovery would that be?
Yeah, maybe I'm not directly answering your question, but I have an ambivalent feeling about this issue. If you look at how many stars we have in the galaxy, life must be there. But on the other hand, professionally, I'm really asking the question about what made our planet habitable at all. And it really seems like a miracle that our planet is habitable. So, yeah, I really don't know. I really have an ambivalent feeling about this question. But anyway, it really makes us ask good questions on and on and on. And that's what I like about this question.
So let's jump into some of the details. So, Aude, if we can begin with you, especially since what you're working on is right here in Australia, of course. You know, the Square Kilometre Array is a device that may give us insight into this very question about other life out there in the cosmos. Can you tell us something about what that device is and how it potentially could detect signals? So we started doing SETI in Australia before the SK started. So Parkes, the telescope in New South Wales, has been, I think, dedicating 800 hours in total to listen to signal in space. So the idea is to combine radio telescopes with very powerful computing and algorithm to make something out of this signal. And now that we are planning to do the SKA, so I think in total the SKA is going to be 512 stations in Western Australia. Next year it's going to be already operating. I think we're going to have 6 antennas, and then the next year 20 additional, and then 60, etc. In a couple of years, we will have in Australia a capability that never exists before. So
with that capability of listening to signal and whisper far, far away, they're going to be always some algorithm running in the background. So the ASK will do its first purposes to look into astronomic discoveries. But always in the background, there will be some algorithm running out so that we can find some signal who have a pattern that are not something produced by a natural object or something that would come from a natural source. So the whole ideas, and I think Thomas can talk about this much better than me, but that's what we call technosignature. Biosignature is, can we find some bioorganism somewhere? And this is really looking into the pattern of the signal. Is it something that's being produced by an intelligence somewhere? So
sure.
That's the technosignature.
And so you already made reference to it, but Thomas, maybe we can take it a little bit further. So, in the old days, when we spoke about SETI, it was just, these radio dishes just, looking for some kind of signal. But can we now go beyond that approach to look for more refined signatures of life out there?
I think there's a huge evolution that happened in this field. As you said, from listening to deep space to really, frankly, bringing the tools of AI and machine learning to massive amounts of data, and not only looking at the radio space, but also at the visible. In addition to that, see what happened, and frankly, sometimes we forget how close these discoveries are to the present. Roughly 6 years ago was a paper that came out that basically said, look, if we look at the statistics of planets outside of our galaxy, for each star in the universe, there is at least a planet. So for me, what happened now, and what we have spent a lot of time on, is looking at the atmospheres of those planets. And with the James Webb Space Telescope, for example, we can look at them, and frankly, not only would we hear kind of noise, like radio noise, from, football games in various places. I know the football is different depending on where you go, right? But the excitement is the same, or more here, frankly, in Australia. I've been watching at the TV. It's incredible what they do. Anyway, so it must hurt enormously, by the way, but
some of them are insane. I don't know how you guys do it without equipment, helmets and things, but that's for a different program.
But also really looking at the atmosphere. See, the atmosphere really changes because humans are here, and because especially bacterial life is here. It totally changes the atmosphere. So looking for those signatures as well is really one of the goals of technosignatures.
Yeah. So, if we were looking for signatures of what? Sort of the remnant, the detritus, the pollutants that come from technological advancement, they could be doing that for us too, right? So our garbage may well be the signature that they're looking for to find us, right? And so do we need to be concerned about that? Do we worry about revealing ourselves? Is this something that we're certain is an enterprise that will not ultimately be to our detriment?
Well, I would say if the answer to that question is yes, I would say, oops, because it's too late, right? Since since the 40s, we've started to emit in all directions. And frankly, I think there are two ways at looking at everything new. And I think it's important to look at when we take a new technology and kind of a new approach, it's important to kind of say, what if? And to think through that and really make sure that there's no damage.
Right.
But generally speaking, I think it's also important that we kind of dare some of these. I mean, frankly, all these movies you showed earlier, right? They're people daring things that were not done before. And on the average, those things is what brings us forward.
Yeah. So, almost everybody made reference to the fact that from a probabilistic perspective, you look at a tiny patch of sky, you stare at it long enough, say with Hubble or the James Webb, you see an enormous number of galaxies in the tiny patch. Each galaxy has, hundreds of billions of stars. As you just noted, each one of those has a planet. So the odds seem good from that perspective. But for somebody, namely you, Thomas, who spent so long at NASA, do you think the tools that we now have are likely to find that life if indeed the probabilistic reasoning is correct?
So look, kind of what happens, it's almost like climbing a mountain in the fog. You never quite know how close you are to the top, right? So the way, see what happened at NASA that was really important, and similar things happen across the world, is in 2018, the purpose statement for NASA was changed to include finding life elsewhere. So the purpose of NASA, in part, together with Earth observations and exploring the universe and with humans, having an astronaut corps, is to find life elsewhere. So what I've done when I was, as a NASA head of science, I tried to do all I could. For example, bringing back samples from Mars, the reason for that is to find, is there a kind of extinct life on the surface of Mars? Why wouldn't there be? 3 billion years ago, there was a lot of water, so forth. Going with Clipper in 24 to Jupiter, trying to see whether Europa is a habitable world, and also kind of exploring other things. So for me, I think there's a very good chance. So the way I do this, I always try to see, do I bet my house? It's like really bad if the bet goes wrong. Yeah. Do I bet my car? And I have a decent car, but not a Ferrari.
Or do you bet my life?
So I bet a car that in 20 years we know the answer, at least for bacterial life.
Well, that's pretty good.
Yeah, I mean, based on a lot of the things we're doing.
It's putting your money where your mouth is. So Kirsten, ESA is certainly involved deeply in trying to find exoplanets. And so can you give a sense of the projects that I guess are underway now or in the planning stages to advance the list of exoplanets that we have discovered?
Sure. So ESA is focusing on conditions for planet formation and looking at the emergence of the potential emergence of life. So already in 2019, there was a launch of KEOPS. And KEOPS is there to look at planets that were already aware of their existence, but try to measure their mass as it passed in front of its star. And from that measurement, then measure the size to estimate the mass and density of this planet. That's the first part, already launched in 2019. Then it'll follow with a Plato mission. Plato mission is going to be looking at Earth-like planets that are going around our sun-sized stars. And this will essentially let us know if there's planets in this habitable zone where there may be the existence of liquid water. And then following that, we're going to have the Ariel mission. And Ariel is coming in the next decade, and it will really focus on looking more and more into the atmosphere of these planets.
And right now, how many exoplanets have we found? It's in the thousands.
It's a little bit over 5,000.
A little over 5,000.
Yeah, it's over 5,000 or so.
And of those, the fraction of those that are either Earth-like or in a habitable zone associated with the particular star, what number are we looking at there?
We're estimating that we'll observe at least 1,000 or so in that zone.
Wow.
So at least in the first mission of KEOPS, looking at planets that are roughly the size of between Earth and Neptune size, and then in that zone that's more in the habitable, but it's hard to say yet.
Yeah, so it's about 20% or so, depending on how you look, of everything we found are are candidates in that zone.
Which, with the numbers we're talking about, 20% is basically one, right? A fact that hardly changes anything.
And frankly, you go to a meeting with a lot of professionals, they fight about that number.
Right.
And some people have actually argued that the number should be higher because there's certain biases. Because see, it's a lot easier to observe big things. And a lot of the big things are not Earth, like Jupiter and Saturn are much bigger, and Neptune and others are much bigger. So there's a lot of chances.
So given that, Masaki, I just want to go back and drill a little bit down further on the question that I began with the following framing. If we do discover life beyond Earth, well, it took life on this planet roughly 1 billion years to take hold and, on the order of billions of years for intelligence to emerge. So billions seems to be the relevant timescale when we're talking about life and intelligence. So with that, it would suggest strongly that would be an incredible coincidence if we discovered extraterrestrial life, which was at roughly the same level of advancement as we are. Either they're going to be well behind us or perhaps well ahead of us. And we're talking ahead with scales of billions of years. We know what happened in just like 100 years on this planet with human beings. We're so different technologically from what we were 100 years ago. Imagine what we're going to be like 1 billion years from now, if we're here, of course. So if we take that into account, does that change our perspective on the impact of, say, encountering extraterrestrial intelligence when we recognize that we probably won't be able to communicate with them, not because the languages are different, it's just we'll be at such vastly different stages of development?
Well, that reminds me of a joke that if you're too intelligent, you might start killing yourself and you don't stay long on the planet. So maybe we're in that crisis now, but maybe that was a bad joke. But
yes, right. Exactly.
Well, should I stop here?
Feel free to continue.
Yeah, but you keep on asking about life. But for us, it's the prebiotic evolution that already seems like a miracle. So we have just completed a mission by the name Hayabusa 2. We returned samples from a primordial asteroid, and we found 20,000 organic molecules inside. So it seems like we have a starting material for life already, even on the primordial asteroid, a small body. But how do they evolve into something that's useful for life, and how life managed to use them to maintain life? I think before wondering about intelligence, I think that's really a burning question for us. And I think we are having a nice starting point to address that question. I think that's where we are now.
And so that's actually a remarkable result that you just sort of spoke to with pretty even tone, right? I mean, some of this was announced just a couple of hours ago, if I'm not mistaken. The discovery of uracil, one of the nucleotides in RNA. You now have a definitive discovery of that complex life-sustaining molecule from the mission that you described. Is that correct?
People's been wondering whether we find it or not. But now the scientists, now that we find it, they take it for granted, and they're starting to ask different, next level questions.
Absolutely.
And I really enjoy this, dynamism among the scientists.
Yeah, no, absolutely. The crazy and shocking results of one generation become the things that you just shrug your shoulders in the next. So Aude, just how about on that perspective of would you be excited or frightened to encounter life that's 1 billion years more advanced than we are? Is that the likely thing that would happen if intelligence is as commonplace as life itself?
Very excited. Otherwise, as Thomas was saying, I think that would be an excellent discovery. And we have to say that the Hayabusa 2 was landing here in Australia. I think that was a very proud moment here. And I also heard today that you are going to give some samples to University of Queensland here. So you're going to have some sample to play with and doing more discovery there. Curtin University in WA as well. So that's quite something, that being able to have your hands on a sample like that and do studies and discovery. So yeah, that's very exciting.
So Thomas, and we'll move on. I just want to ask one other variation on this theme. If we were to find extraterrestrial intelligence that was, say, 1 billion years ahead, and then everything that we work on so hard, everything that we care about, we strive to work out Einstein, general relativity, modern age, string theory, unified theory. If they've solved it all, and we were like let's say the analogy of we to them is like ants to us. I could imagine that would have a pretty profound but negative consequence to life on this planet, where it's like, what does it matter? They figured it all out. They're so far ahead of us. Like, what's the point? Can you imagine that could be where it goes?
Yeah, when you asked Masaki, like what happens if they contact us, I just remembered I gave a talk in New York earlier this week, and some guy told me they're following him, people from another society, and yeah. So I've thought about the same, Brian. For me, that the fact that we're at the same, the question, the likelihood that we're at the same level of evolution largely, that likelihood is zero, because we're not going to other stars. I'd like to figure out how to go to other stars, but we have not done that, and how that would affect, right? Like everyone, we have had experiments like that, in one part of the world that was in a different kind of evolutionary environment, went to another part and basically said, I'll tell you what to do now. And generally speaking, those are bad experiences.
And there are only 100-year differences.
Exactly right, only 100 years. So if it's, somebody asked me, it's like, what's the first question you ask them? And of course, the first question is, how did you do it? Because the worry I have, right, and together with others, especially this week with the release of some of the climate data, is like, hey, like, how do we make sure that we kind of take care of our planet? Because that's what they managed to do and became multiplanetary species. I've thought about this, and I don't know whether I have a good answer, but I worry too, just like you're indicating.
Yeah. Stephen Hawking was fond of saying that any time a civilization was visited by another, visited in quotes, it didn't usually turn out too well for them. We see this repeated all across our planet, so one can imagine it replicating in a more dramatic way across the cosmos. But Masaki, I just want to go back now to the discovery that you made reference to. So the work that you have been doing with the Japanese space program has been trying to land, and you successfully did, land a vehicle on an asteroid. So you can just tell us about the motivation for that, what you've done. You've already made reference to the results, but just give us a little backstory on that.
Yeah, thank you. So we've been to a primordial asteroid by the name Ryugu. The reason we were interested in primordial asteroid is because Earth was born dry. So somebody from the outer part of the solar system must bring water and volatiles, including organic compound, to make our planet habitable at all. So we've been to the primordial asteroid, who must have brought those materials to make our planet habitable, and got the samples back to make sure that they are the who made the condition available for the habitability. So sample return mission was a big technology challenge. We have been to a small asteroid about which we don't really know before we get there. And after getting there, all the details, and the engineers start to make the planning to get the samples from the surface, which we managed to do perfectly. And then returning samples back to Earth is also a big deal, because you really have to pitch the capsule precisely into the desert in Australia, Woomera. And we have to collect the samples swiftly and bring it back to the curation facility in Japan, so that we don't have the contamination from the terrestrial environment on the samples. We did all of them perfectly almost, so we're really proud of the mission. And the results we're getting from analyzing the samples is really, really great. And we're really proud to be offering the science opportunities to scientists on the globe.
And so do we now have a definitive answer to the origin of water on Earth, or is that still an open question?
Primordial asteroid is now, for sure, one of the strong candidates that brought water to Earth.
How about water that was already in Earth and outgas? Is that still a contender or a contributor to Earth's water?
Well, the strongest rival is the comet, and then people can analyze the isotopic ratio of hydrogen to make sure that about the mixture of primordial asteroid versus comet, about the how much has been contributed by which about the origin of water on Earth. So that's the big debate happening now.
And so, yeah, go ahead, Thomas.
So I think if you went to a science meeting on this, what the prevailing thought is today that it's really a mix of stuff that comes from the inside of the planet and from the outside, and really Masaki said it well, right? It's comet asteroids used to be the things in school that
asteroids were dry, right?
Exactly, they're dry.
Right?
It's like
yeah.
Absolutely not, right? Wherever we go, we find water on these asteroids, and there's a lot of surprises also, how the structural integrity of this thing. I remember Masaki, he picked up, the Hayabusa 2 picked up a sample. We did one with NASA, and what we did is we had the arm that went down, and I remember sitting there on the chair, and the arm hit the surface. And we had an accelerometer in there to make sure when we hit something hard, we fly away. Well, the arm went right in for a half a meter until the spacecraft, because of another measurement, basically said, hey, I better back off. So don't think of
so they're not really solid rock?
No, yeah, it's more like a ginormous, like what's under my bed if I don't clean enough, like dust, right? Like it's a ginormous dust bunny. And like when we hit an asteroid with a spacecraft called DART, same happened. Like enormous amounts of stuff came off. It's not rocks. Many of these asteroids are not rocks.
So do we need to be scared of being hit, or is that more of a myth? I mean, getting hit by a dust bunny doesn't seem that frightening.
It depends how heavy it is.
Yes, right. That's true too.
So look, I mean, it's just different. My point is that there's a lot of surprises when we look at these bodies, and I looked up your resume, of course, and
thank you.
We did our education within 5 years of each other, and I remember, right, a lot of the things that we were taught. Like, for example, it's really hard to make organics.
Yeah.
And the answer is, it's raining organics from the sky,
right?
Like from the beginning. And for me, it's just like there's just a lot of lessons learned here. And in this golden age of exploration, many of the things we learned just were wrong.
So, but all the work that's usually spoken of, like Harold Urey, putting a bottle that has all the sludge that you imagine was early Earth, and then hitting it with bolts of lightning, just electric currents to try to yield organic molecules. Is all of that now sort of secondary because of the fact that the universe is pretty good at manufacturing these organic molecules, and they just came down from space? Is that the paradigm shift?
Yeah, that's a really good question, because people's been happy detecting amino acid or nuclear base in astromaterial samples. But is that the right question to ask? Because does it have to be that particular molecule that raining on Earth, or can it be something more complicated from which you start processing on Earth? So I think that's getting to the burning question now, because on Ryugu we do, in addition to amino acid and nuclear base, we are detecting more complicated molecules that looks useless as it is, but once they rain on Earth and start to get processed, they might be the nice starting point for the subsequent synthesis. So I think that's really the burning question emerging now.
Yeah. So Kirsten, ESA is also, I guess, even working with the Japanese Space Agency to have a Comet interceptor to take these ideas even further. Can you tell us about that work?
Yes, so the plan that ESA has is to fly 3 spacecraft to a comet and take measurements simultaneously so that you can then get a 3D view of the comet. Maybe I hand over to Masaki-san for more details as well.
Yeah, so what we really like about this Comet interceptor mission is that it's going to be in a L2 point, waiting for something interesting to come down to the inner part of the solar system. like an interstellar comet or a comet that's coming into the inner solar system for the first time. And once we get that news, once we know that it's coming, then we'll send the spacecraft to make a rendezvous. So this is going to bring us the very first image, close-up image of an interstellar object, or maybe the comet that's making the first encounter with the inner part of the solar system. So it's really going to be something that we never seen before. So I really like it that we are part of this mission.
And so the L2 point, you mentioned it, the Lagrange 2 point. Anybody want to quickly just review what that is and why we would put a device at that location?
What you want to do is not leave the Earth, but be in a place where we don't need a lot of fuel to get going.
Right.
So if you go to L2, which is behind, you looked at the Earth, kind of if the sun is this way, L2 is that way at 1.5 million kilometers or a million miles or so in that direction. And so what you want to do, you can park it there, and it takes some fuel, but very little fuel. And like Masaki-san just said, like you wait until something really exciting happens, you put the pedal down and get going. So it's a lot easier to make that happen from there. It's just from a fuel perspective, it's just really the right place. And frankly, by keeping it there, what you can do is make the spacecraft kind of thermally so that you don't have to kind of solve all the problems that you need for a near-Earth mission. So you really solve it for the environment that you want for a celestial body. So that's the other advantage.
And I gather the point is previous investigations of comets have observed them after they've been profoundly influenced by the sun because they have come so close. If we're out there at the L2 point, you're sort of seeing a pristine comet before the sun has done anything to it, and that presumably gives us a deeper and clearer understanding of what's going on. But if we move from asteroids and comets to some of the moons of planets in our solar system, we've been surprised and fortunate to find a lot of interest and interesting things happening. So for instance, in Jupiter's moons, Ganymede, Europa, Callisto, I guess we have now evidence of oceans there, and there are missions to explore the possibility of life on those bodies further. So Kirsten, why don't you start us off? So what's ESA doing in that regard?
ESA has a mission coming up, actually launching in April this year, called JWST, the Jupiter Icy Moons Explorer. And this is actually the most powerful remote sensing and geophysical suite of sensors that we've ever sent to the outer solar system. So we're going to be looking at, as you said, Ganymede, Europa, Callisto, and trying to analyze the environment around these moons, so the oceans or icy shells, the atmosphere of them, their composition and environment. And it's an extremely exciting mission. So with this launch coming up in April, it'll take about 8 years of cruising, and then we'll start to see the data coming from Jupiter. Also, we'll have a chance to see more about Jupiter itself and its atmosphere, the magnetic environment, et cetera.
So it's really exciting, and especially so if you reflect on the fact that here on planet Earth, there are many who think that life may have originated on the ocean floor, hot thermal vents in our case. So it's completely sensible to imagine that life on these particular bodies might be in those oceanic environments. Now, NASA's also going to Jupiter's moons. Is that correct? Those are distinct missions. Are you guys going to sort of bump into each other on Ganymede or something? How's that going to work?
Yeah, so the orbit that the European Space Agency is taking is very different than the orbit that NASA is doing. Our mission leaves in 2024, and it takes 6 years to get there, because what we want to do is what you'd like to do, get in orbit around Europa. And there's let's design that mission. Then you figure out that's a horrible place to be. Frankly, it's the worst place in the whole solar system.
You mean because of radiation, do you mean?
Yes, because Jupiter is this generator of radiation, and frankly, it cooks the spacecraft. I mean, kind of within hours, within days, the spacecraft has accumulated a lot of kind of just kind of ionizing radiation from that environment. So what NASA's doing is kind of do pedal orbit, in which we fly by Europa 40 times or so and kind of scan it that way, but then go heal a little bit kind of farther away. What I'm really excited about is there's one instrument on the US mission that I look forward to. It's a very complex mass spec. Frankly, nobody said that is absolutely needed. Now, here's the reason I was so passionate of putting it on there, and that is that when we went to Saturn, there's a moon nobody could pronounce until it started spitting water and organics called Enceladus, right? And I'm like I remember when the guy from across the hallway came to me, he's like, "Oh, that's amazing! There's alcohols coming out of Enceladus." It's like, you cleaned your instrument with alcohols on Earth. That's why. Go check it again. Of course, he was right. I was wrong. But so the question is, does Europa also burp? Does Europa also eject from the oceans kind of water with whatever is there? If that's the case, that mass spec will be the best measurement of it.
To see everything that's in there.
Yes, absolutely. So I'm really excited for it. Together, these two missions will really advance the JUICE and Europa Clipper will advance our understanding of all these moons. And remember, when we talked about life, we never talked about moons until like the 90s, right? So what an amazing, just another chance to create life in an entirely different fashion.
So Aude, imagine that, in one of these missions, let me talk fancifully, poetically, I don't really know what the device looks like, but imagine, we stick some probe through whatever surface there is, a periscope down there into the liquid environment, and we're looking around and some creature swims to the lens and just gives it a nice lick and keeps on going, right? So imagine we find life. What do we do at that point? Are we of the mindset that we got to get the heck out of there so we don't contaminate things? Are we of the mindset that here's the opportunity to explore and we just crack open the surface and start pulling out whatever we can? What do we do? What's the scientifically sensible and the ethically sensible thing to do?
You're asking a very important question there, but don't be scared. You do always think of, do we go away? And I think we have to embrace what we don't know, and I think that's what we all do in space. We want to explore and discover things. But the point you're raising is very important, and at the agency, at the Australian Space Agency, we are not there yet to do some exciting missions that we've just heard, but we are starting. We're not 5 years old yet, but we're starting wondering what is the science mission we could be doing, because it starts like that, right? Lots of scientists look into what is the next thing we have to discover. And then once you have that mission, you put engineers with the scientists, and the engineers build the spacecraft to find the answer of the science, and that's where innovation happens, and that's magical. We are just we're starting by doing a rover to the moon, and we're asking this kind of questions. There is a lot of rules and guidelines, and there is the Moon Treaty, there is the Artemis Accord, there is a lot of agreements to do this exploration in a right way, and we call that space sustainability. We want to make sure that we don't pollute where we go. Now, not everybody plays the game. It would be good that everybody plays the game, but we have to make sure that every time you launch something that goes on a probe, a probe that goes on the planet, or you make sure that it's no microbes, no nothing. It's ultra clean, and that's one of the reasons why all this assembly of spacecraft are happening in this very clean
environment. Yeah.
So you have to be very, very careful. And when we look into our mission going to the moon, we're asking all these questions: where are the places to land, and when your equipment dies, where is it going to die? Are we going to decide that on the moon there is a cemetery where all the rovers in end of life go there, and then that means there is some material that we can reuse when time comes. There is no rules yet written for what we're going to do on the moon. There is guidelines, but there is no real rules.
I mean, that's kind of scary in a way. I mean, right here we have representatives, leaders, or past leaders of 4 space agencies that are fairly friendly countries, right? And there are other space agencies where it's perhaps a little less friendly. And there's no, I remember like as a kid in Star Trek, there was the prime directive, right? Not to interfere, broadly defined, and they broke it every episode, right? And so can we get to a place where there is a worldwide agreement on the right way to behave in these circumstances? Is that naive to hope that we could get there?
Well, I don't think it's naive. I mean, we have the COPOS, the Committee of Out of Space Policies. So people are meeting together. All the countries are meeting together, and all the countries, China as well, Russia as well, and they're agreeing on guidelines. They're ratifying rules. Some are just guidelines, but that exists. There are forums. They are meeting twice a year to drive all these rules. I think we have good guidelines for all the activities around the Earth. There's 21 long-term sustainability guidelines, like when you launch a spacecraft, after X number of years, it needs to burn back in the atmosphere and free the space. So I think there is a lot of things happening around. Now, how do you enforce that? Do you have a space police? Not yet. So there is still a lot of questions on how do you enforce all this. But for the cislunar, so all the space between Earth and the Moon and on the Moon and around the Moon, there is nothing. And I think we have to be, I'm speaking about the Artemis Accord, there is 22 people who have, 22 countries who have signed this Artemis Accord. So how are we going to go back to the Moon together? We're sharing best practice and we're trying to be proactive on this. And how are we going to do this together? But it's not straightforward.
Yeah. Thomas, did you want to add to that?
No, look, I mean, before we don't interfere with each other, which is absolutely essential, right? We want to be sure that agencies from all over the world can go explore. That's what we want to and can do. Before we do that, we need to be absolutely transparent what we want to do. I'm going to go to that body. I'm going to fly there. That's what I'm going to do. I'm going to try to land there. That's the transparency comes first. So for us, that's really what the Artemis Accords are about. It's like we're committing that we're telling you up front what we're going to do and what we're going to try, what are the payloads that are there. And frankly, there's some rules we're going to use. For example, in the areas of the Moon where there's a lot of potential water resources, we're not going to put a lot of pollutants in, right? So we want to make sure that kind of, and actually we quantify what the fuel is that we're bringing. So somebody can know at the end that's what went in there. And so for us, transparency comes first. I mean, to me, we need to figure it out. See, the issue is it's a new problem. Like we haven't been to the Moon kind of, with humans for a long, long time. And, besides the Chinese lander on the far side, and there haven't been many other landers for a long, long time. And frankly, the Chinese told us where they're going to land ahead of the landing, which is the very transparency that we want. And so, but we're going to have a dozen missions in the next 2-3 years to the Moon. Every one of the agencies that is represented here has at least one mission. The U.S. is launching 3 times next year.
Yeah.
This year alone, 3 times to the Moon. And so it's an important thing, and we need to solve it.
So let's turn then to exploration of the Moon, and Aude, perhaps just give us a sense. There are some who I would imagine, when thinking about humans going to the Moon, would say, why would we do that? We got there. There's not a whole lot that is there that is to explore. Why would we put the resources in to go back to the Moon? What's your perspective on that?
We started on the land, we went on the ocean, then we went in the air, and then low Earth orbit. Moon is next, and then it's Mars, and then we continue. That's in our human nature to explore and go further and further.
But do you see it as a stepping stone?
Absolutely, absolutely. And I think whatever we learn to live in a sustainable manner on the Moon, there is always learning back for making our life on Earth better. We always, I like to say that we do space to improve our life on Earth. And even when we do space exploration and when we send humans on the Moon and beyond, it's to understand Earth better, to understand the formation of the Earth, to understand where we are going, where we are coming from. Everything, I mean, NASA especially, every year they are publishing a volume of all the patent and invention that we are using on Earth because of all this exploration we've done. So by going on the moon, we're going to improve life on Earth, that's for sure. And that's going to be a test bed to go further. But before we go to the moon, before sending people on the moon, we need to start preparing everything. And I think that's where Australia has a very big role to play. Because of our mining industry and remote resourcing industry, we know how to do remote operation very far. I mean, I always talk about that story. The first time I went to see a resourcing mission control in Perth, I entered in the room and I thought, am I in Houston? Did I took the wrong door? There was a gravitas in this room. There was a lot of people working, concentrating, and different pods organized. And I approached the pod. There was one lady here, and she was drilling. She was actually controlling 10 drilling operations that were happening 2,000 kilometers away in the Pilbara region. So far away, harsh environments, hot, cold, a big like space. 2,000 kilometers away. The space station is 400, 500 kilometers away. And she was doing all that using communication via geosatellites, so 36,000 kilometers high, so a bit of delay. And one person doing 10 operations, when usually when you have a rover on Mars, you have one rover and 200 people dealing with this. So that was interesting. So we have expertise and experience in doing this. And so this is what our Trailblazer rover program is about. We want to show to the world that we are the best in doing remote operation on the moon. We can prepare the moon. We can find, analyze regolith, extract resources that we need from that. And we can bring that expertise to the moon. And whatever we're going to learn there, we're going to do things better on Earth as well.
And so you're leveraging an expertise that Australia has to contribute something iconic to this mission. Masaki, Japan is taking a similar tack, right? You also are leveraging something that you have gotten particularly good at, which I guess is precision landing. Can you tell us about that?
Yes, we have a small technology demonstration mission to show that we can do the pinpoint landing. And that lander also has a way of we call two-stage landing. By that way, you can land on a rough terrain. So we will have the technology to do the pinpoint landing and the way to land on the rough terrain at the same time. Then we will develop our program. And that program is driven by science objectives. But the design is that if you want to develop your skill, if you want to develop your technology so that you can explore relatively freely on the surface of the moon, maybe science is a nice precursor. So that was the thinking behind our program. So we will try to deploy a network of seismometer and a network of radio telescope on the surface of the moon. So that's our future program.
And so, Thomas, you already made mention, but I'd like to go into it a bit now, that the Artemis program has recently been initiated. And the goal there, I guess part of the goal is to have the first permanent base station on the moon. As Aude said, use that perhaps as a stepping stone to Mars. Where are we in that program, and what are the key things that we need to get done to push this program forward?
Yeah, so 2022 was a really important year because Artemis 1 lifted off the launch pad. And of course, that was together with the European Space Agency, with the European Service Module, and at the Orion. Just an absolutely incredible, start to that. We are now working with our partners, with NASA, and all the partners we're working on really two missions. The first one is to get the first kind of humans back to the moon. And in this case, like the Apollo 8, go around the moon and swing around and come back. And then the next one, of course, is to have kind of an outpost, because remember, what we want to do is go to the moon and have this station, but also learn how to go to Mars. And so it's this gateway that we're working together on. All of this comes to will be launched in 25. And so.
And is that more or less on track, on schedule?
So probably the one thing so it's roughly on track. Needless to say that these things are never easy, right? I've done a lot of missions where I went in front of Congress, said we're exactly on track. Then I come back to the office and said, oops, we found some problem. It's like, okay, what do I do now? So look, I mean, the team is really great and very motivated. We want humans back on the surface of the moon, because what you said is we want to have a research station like we have in in Antarctica, for example, in which we really can have humans there and also robots that frankly do research together with humans, and we can go after the questions that we have in our minds.
So you mentioned robots, and that was a question I wanted to go to. Some would say that it'd be so much less expensive to not have to worry about life support systems if we just sent robots. So Kirsten, what do you think is the strongest argument for why it's important that there's actually a living human being that, say, goes on this mission to the moon or Mars or beyond?
I think the key thing is the human's ability to perform complex tasks. The capability to have decision making, be able to find creative solutions if anything goes on. When you send a robotic mission, you're just dependent on the tools you came with. You can't have any creativity of making a solution on the spot and coming to that. And then, of course, I think, a famous NASA scientist also said that, a human can do in a day what a robot can do in a matter of months sometimes. So I still believe that as we progress towards the challenges, first robotically, of course, initially, but to really learn how to live and work on another planet, you're solving so many different technical challenges. And this living environment is really like a microcosm of our own Earth. So as you try to use the resources you have in space and you look at all the different challenges from food, from oxygen, from water, how to solve these in a sustainable way, there's huge benefits that we can bring back to Earth when you look at climate change and living more sustainably.
But we've already seen, for instance, that if it came to an issue of, creative, smart humor, ChatGPT already takes care of that, right? So a little more seriously, what if we imagine there are sufficient leaps forward in artificial intelligence? Couldn't we have sufficiently directed and smart robots that really could do what humans do, at least in the limited tasks that they will be presented with in space exploration? I mean, Thomas?
Yeah, I think robots are going to get better and better and better. I think what we're trying to do now, and we have kind of rovers in which we let even Perseverance on Mars right now, it drives like 10 times farther than Curiosity because we train it to make decisions and so forth. And we're going to push that pedal down more. But the bottom line is, I always ask the question, well, how do we do research on Earth? So, there's really dangerous places on Earth like volcanoes, right? What do the best places that do research on volcanoes, how do they do research? And the answer is they put humans there together with robots. So humans go to the volcano together with robots. And for me, that humans are such an important contextual kind of decision maker. Now, in 100 years or even in 30 years, where will we be with the robots? I really don't know. We should advance both and adjust that balance as we go forward. But I have a really hard time kind of coming up with a prediction in which humans are not in the loop somehow or are there somehow. Also, don't forget, we relate to humans very differently than we relate to robots as well.
That's true, but I'm not sure the relevance of that last point.
For us, one of the reasons we do exploration is to inspire.
Sure.
Not just because of the science result that gets written down. It's to inspire others to kind of do careers that are really hard, like, be explorers, be innovators, and so forth. And so for me, humans they're really inspiring in a way that a machine often cannot do.
So given all that, Masaki, and given the dangers of putting a living being in a spacecraft that's fired off towards, say, the moon or beyond, does Japan have as one of its goals landing a citizen on the moon?
Yes, that's often spoken as the near-term goal. Sending a Japanese on the surface of the moon. That's part of a reason we have recruited new candidates recently. But hearing all these arguments, let me try to be provocative here. Maybe I'm saying something wrong, but still. I'm not from the human exploration division, but when I look at them, they treat astronauts too well. Maybe they are spoiling the astronauts. And what I mean is that why do we have to have humans there? Because we want her or him to be bold. So if we treat the astronaut as somebody from like a celebrities and tell her or him not to do something, then what is it? Like not well, of course they shouldn't do something dangerous, but you know what I mean. So astronaut has to perform its role, and role will be more challenging in the future because it has to be something that robots cannot do.
Each of your countries is there an explicit sense of what level of human catastrophe the space program would be willing and able to sustain and continue to move forward?
I mean, catastrophes are an ever-present possibility.
Yeah.
Right? I mean, frankly, I don't know, running at NASA and even launching the James Webb Space Telescope, if there are $10 billion sitting on top of a rocket, you start to get into Stoic philosophy, right? Because the thing is like, how do you deal with that pressure? And the answer is, you're not in charge of making no catastrophe. What you're in charge of is reducing the risk to whatever is possible. So there will surely be catastrophes in the future. That's what history tells us. That's what's going to happen. And that's why it's so important that the why behind our programs that is a compelling answer. We have a compelling answer for that. Surely we will survive these catastrophes if the why is correct. But I think that how we do the research, how we interact, how robots and humans interface with each other, that will shift over time, just how it has shifted in the past. I cannot imagine going to the moon with an astronaut without having robots there. And frankly, I don't want a vehicle where the astronaut can drive, and when the astronaut leaves, the vehicle is dead. I want the vehicle to keep driving for the next years. It makes absolutely no sense to discard a perfectly good vehicle, right? But that's what we did in Apollo, right? So for us, I think, yes, there will be challenges, surely will be, but let's make sure we talk about the why a lot.
So one of the other big shifts that's happened in recent times, of course, is it used to be the case that it was just governments, it was just nations that had their space program, but now we see that private business is doing this as well. So what is the impact of, say, a SpaceX or Blue Origin, whatever the leaders might be, on the kinds of things that we're talking about here? And in particular, Aude, do you have a sense of the risk analysis when it comes to governments? I presume one of the largest is, the benefit of what we're doing versus the lives that it might take. But from a business perspective, it's the profit that you might get versus the loss that you might sustain. It's a different calculus. And what does that do to the future of space exploration?
I see this differently. For me, space, either there is business model So if I do a communication satellite, I can sell the service, I can make money, so let the industry run that. However, if there is a new technology that needs to be developed and become operational, I think that's more the government agencies that needs to develop that technology, like optical communication just now is the next thing. Once it's proven that it works, leave that to the industry to run. And, you know, we saw the picture of the landing of the moon in black and white and fuzzy picture. When we're gonna go back, we will want to have like high definition surround sound. So you're gonna have, you know, optical communication is gonna be important. Earth observation, you know, weather, what weather is gonna be tomorrow, space weather, what kind of impact is gonna have. I think this is a government role to provide these services, so that's more a government mission. I always see this, is there a business model or is there no business model? And I think as soon as the industry can run that and make profit, let's leave that to them. And then the next risk, I mean, going to the moon is risk. As soon as there's going to be a lunar economy, things are going to change again. But to your other questions, you know, SpaceX has disturbed a lot of things, and disruption is good. I think everybody woke up and said, oh, what do we do? But I think government space agency will always exist to work together to design the next mission. And then once your objectives are defined, you let the industry delivering that. But you need to have the expertise in your agency so you can define this mission. You can know if it's going to be a 1 billion mission or a 50 million mission. So you need to have this expertise still in the agency, but let the industry run it. And if they want to do bigger objectives than the one you set, fine, let them run with it. But there is a role with both. And I don't think it has changed so much. I started my career at ESA, so it was old space. I'm now in the Space Agency Australian New Space. And I think I take the best of both worlds. Before, agencies were prime, so we were building a product. I think today we're customers, we buy a service. Like send me a rover to the moon and move regolith from A to B, and once you're done, I pay you my check. So it's a governance that has changed, but there is still work for the agencies and there's still work for the industry.
So that suggests a sort of happy symbiosis between government and business, which in the best of circumstances can happen. But what role should the originators, you know, the governments, play in constraining or restricting or regulating what the private companies do? I mean, Elon Musk, as we've all heard, has spoken about having a base on Mars. Like, so what role should the government play in restricting that? I mean, for instance, should we allow there to be Twitter on Mars?
No. By the way, I was really wishing I could live tweet what Masaki-san is saying here. We get a lot of followers about the astronauts, but look.
In a few minutes you can do that, no doubt.
No, look, I mean, so first and foremost, right, kind of it's every government's responsibility or every desire that we don't keep doing the same thing, that there's kind of commercial players that start picking up, that jobs are being created, and frankly, the benefit to the government, in the case of SpaceX, let's just take that one. There's other companies as well, and some of them from the region. You know, Peter Beck with Rocket Lab is incredible innovator, right? Kind of over in New Zealand, and you know, so what happened in the last 10 years or so? The cost of launch has gone down largely 30%. So, kind of as a science, person who likes science missions. Yeah, what happens every once in a while, you know, like I'm like, that's really great because I actually can do more science missions now.
But where did that come from? Is it the efficiency of the capitalist profit motive that found ways to squeeze down the cost?
Absolutely. I mean, if you go to Florida at 2 a.m. anytime and you basically go open the door for SpaceX, there's a number of people working there. And there's rockets right there, like 5-6 rockets being worked on, because one of them is the one for 2 days from now. The next one is the one from, 5 days from now. And, so the point is, it turned into a factory. It's not like these exquisite once a month or once a year type of rocket. So it's a very different way of doing it. And for us, that has helped. But there's worlds between the exquisite stuff and that, right? And frankly, I would really like multiple competitors, right? In every segment, I want more than one company because I want to make sure that we don't overpay.
Right.
So we want to regulate, of course. We want to regulate, and I think that's really important, that we make sure that common resources, whether it's certain orbits or whether it's how we deal with, poisons or how we deal with other destinations. I think we want to really think about that. That's what governments do. Together with other governments, really figure out that we don't, take off the table future exploration. For example, I know ESA is really worried about that the same way we are.
Right. So just a couple more questions before our time is out here. In terms of a permanent base on Mars, how far away from that are we? And is it something that we should do? Should that be a near-term goal of the activities? Masaki, thoughts on that?
We have a sample return mission from Phobos, so which means that we will get to Phobos and coming back. But our interest there is
and that's
primarily,
of
Mars, course,
right?
the sample return mission. Yes, that's the moon. That's almost like an international space station of Mars in a sense, because it's it's an orbit circling around the planet at a very low altitude. So our motivation is to understand Phobos better, because that may, instead of having a base on Mars itself, maybe we may have a base on Phobos, like a space station, and perform our exploration of Mars. So that there's an idea there. So that's our kind of hidden agenda behind our MMX mission.
And Kirsten, what's ESA's disposition on a Mars base?
A little similar to what Thomas said earlier, a step-by-step looking at robotic exploration, but with a view of potential human exploration of the planet. Right now we have the launch of Rosalind Franklin that was supposed to be in September last year, has now shifted to 2028. And this rover is actually going to visit a location in Mars that's 300 million years older than any other location we've visited already. It's going to penetrate down with a drill to a depth of 2 meters. And at that depth, we think that there's a good chance of finding sample that has evidence of organic life in some way, because it's been shielded from radiation in the environment with these 1.5 to 2 meters of soil above it. And so, this could be revolutionary, and tied together with this Rosalind Franklin mission. Of course, we have the whole Mars sample return mission in addition that we're doing together with NASA. So just the complexity of already Perseverance rover picking up the samples, later having the sample retrieval lander from NASA with a European sample transfer arm picking up the samples. The first ever launch off of Mars to send a capsule into space, be captured by the Earth Return Orbiter, and then eventually have this capsule re-enter the Earth's atmosphere for being able to retrieve these samples. So that's a hugely complex mission. And being able to prove that we can do that is taking us one step further to say, yes, indeed, we could look at a human mission to Mars eventually. Now, of course, in parallel, we're studying a lot of the effects of microgravity, isolation, radiation on the human body to also answer the question, could humans even survive this trip? So it's worth already working our way towards that in parallel, and then working on this robotic mission and such a revolutionary way of doing science and getting samples back, et cetera. So the choreography is just not like nothing we've ever done before.
Sure. But I'm assuming that NASA's disposition, and presumably all the space agencies, is that this is a round-trip journey. It's not a one-way mission for the individuals who go on this. Given that, would we have to bring all the return fuel and all the resources, or do you imagine that there'll be some way that we could mine in a manner that would allow us to get the fuel from the target as opposed to bringing it ourselves.
So yes, we want to go to Mars, absolutely, with humans. And the first trip, we're going to bring the fuel because it's too hard to solve all of these
Will you send it separately, like a FedEx package that's there on arrival?
You go land the food, you go land the fuel.
And you know it's there if you do that first.
Exactly right. Yeah. You precision land it, then you go land the lab, the science lab.
Yeah.
So basically one morning, the humans land, and then they go open the door, and it's like, let's get to work. Right. Here's the food. Here's the lab. And so you do that, and then you come back after so and so much time. So my guess is we'll start working on that in sincerity, perhaps even developing it in the late 30s. Right. So for me, that's where I believe where the aspiration should be.
Yeah.
And I think people expect that. I expect that we go past the moon. I mean, for me, there's excitement about the moon itself as a celestial body, but God, Mars is way more exciting. Together with Phobos, I agree with Masaki. We need to keep our minds open as to how we're going to use this environment, because it may very well be that the right way to do it is actually make Phobos the base and then go down for so and so much time and come back up, right? So that may be a lot cheaper in terms of fuel or overall research.
And just since we're almost out of time and we can speculate here, so let's say this succeeds, 30s, 40s, maybe something of that sort. Is there a next step? Are we bumping up against the edge of what manned or human space travel can accomplish? Or are you imagining that we'll go to a moon of Saturn or Jupiter or something?
Absolutely, right? I'd like to go to Titan. I'd like to put that. Somebody said, let's go to Europa with humans. I'm like, let's not do that. Like with all the reasons we already discussed. But Titan is it's an amazing landscape and, has an atmosphere. It's a lot easier to land on Titan. I'm sure some other people would come up with other candidates. Look, exploration doesn't stop.
Yeah.
Where we are, though, is we're making enormous progress right now on both the robotic and human exploration side. And I hope like in, a couple decades later, there's people on this stage and they are just absolutely excited with the destinations that they're looking for.
Well, I can tell you from a personal perspective, there's not a chance in hell that I would go on any of those missions. Would any of you go? Would you go to Mars?
Not the first time.
Yeah. Anybody else willing to go to second or third?
Yeah, I would
go. We have one taker. Absolutely. Fantastic. So in the last couple minutes, I just want to end with one final question, which is really riffing on the point that you just made. If we were back on this stage, or there are other individuals having an analogous conversation, say 100 years from now, where would you hope we would be in terms of our exploration of space? Masaki, why don't you take it first, and we'll go right down the line.
In 100 years. Yeah. Yeah, I hope we behave better. We learn to behave better with our planet. So, the more we explore, I think we are really we're really understanding that we better understand our planet much better than we do now. So returning to Earth and securing our planet. I hope that's the path we will have in the next 100 years.
Yeah, I think everybody can agree with that. That's a vital goal that we all share. But Kirsten, given that, assuming that Masaki's dream that we somehow overcome all the issues that face us right now, where do you think we'll be in terms of, say, exploring the solar system?
Yeah, I think one of the biggest challenges will be, what would be the next step beyond the solar system, and I really like the idea of being able to explore Mars more, understanding how to use the ice below the surface and make it more sustainable. Also, what the whole choreography would be between moon exploration, Mars exploration, and then next steps. So potentially another moon that's in our own solar system, and also having a much better understanding of our universe as a whole. So if I take the LISA science program that we have coming up, answering some questions about, gravitational waves, understanding how, black holes are colliding, and seeing better understanding also of, dark matter, and questioning key questions in fundamental physics that would be answered if we can understand what dark matter is made of, and is it really an answer to the acceleration of our universe. So these are some questions that are going to be, we'll have more and more data in the coming decades, and then where it will take us by 100 years from now is very, very hard to say. But I think the key point is to keep learning and exploring, and then to then take that and see, looking back on ourselves, will we have robotic missions that are cleaning up low Earth orbit and all the debris that's there? Are we going to be able to improve the situation of our own climate based on what we had learned on living off our planet?
Well, I certainly share your enthusiasm for the possibility of answering the key fundamental questions in physics. That would be enormously exciting. Aude, how about you? Where do you think we'll be, in roughly a time frame?
Echoing everything that was said, but you say hopes. I'm very optimistic, and I think the progress we've done in the last 30 years or in 100 years is going to be even faster. I hope in 100 years we will still have questions to answer, because the day where we don't have any questions is very boring. So we need to continue, and Mars is just the beginning. We need to continue. The big hope for me is I studied space because space brings people together. I mean, look at the different nationality on that stage. When you think of during the Cold War, the only handshake between the American and the Russian were in space.
Space station,
space does things that I've never seen anywhere. And I was lucky enough to witness the first launch of Ariane in '79. So the technology that blew my mind. But seeing 12 different nations, there was no race, no politics, no religion. Everybody was partying because they shared the same passion, the same goal. And this, honestly, I've never seen anything else than space making that happen. And that's the big difference going back to the moon now, is not a race between two countries, it's everybody together. So that's international, so that's a big change. And there is the commercial aspect as well. So I think the next 100 years are going to accelerate things a lot. And my big hope is that we're going to continue asking the next question. Like we said, we found interesting things in Hayabusa 2 mission. What's the next question? We can keep asking questions and keep continue exploring and discovering.
Well, it's a beautiful vision. Thomas, take us out.
Well, look, in 100 years, I want to be a united Earth, kind of with a healed planet. We can do it. We want to come together and do it. We want to work and look at the universe. The universe is more beautiful than in 100 years than it is today even. Remember what we learned about the universe even in the last 2 decades. Looking at the night stars for me is a much deeper experience today because of what we learn about it. It will be the same. And I would surely hope we'll be a multiplanetary species. We've basically have managed to inhabit other places. We're there. Perhaps we're going there for vacations. Perhaps some of us live there. In 100 years, that should be absolutely within reach. And I surely hope that we have basically put an expedition on the way to go visit planets of other stars. Because that's on a timescale of 100 years. That is absolutely within reach. While we do that, we inspire here. And we make really that positive energy that we feel when we do kind of exploration, we make that something that's really part of the DNA of our youth, even in 100 years.
Fantastic. So again, do put it on your calendar for 21-23. Again, it'll be sometime in late March, and we'll have this conversation again. Please join me in thanking the panel here. Thank you. Thank you both.